So in this problem, we're taking a look at the number of plants, maybe in a yard, and the number of bees that are present that the gardener observes. So first of all, we're going to complete the table. So we see that the number of bees present is increasing as the number of plants increases. So first it increases by 3 from here to here, then by 5, then by 7, then by 9, and then by 11. So the change in B increases by 2, increases by 2, increases by 2, increases by 2. We can conclude at this point that this is a quadratic, represents a quadratic function. That is, between P and B, the number of plants and the number of bees appears to be quadratic because the change in the change is constant. Explain the meaning of change in B. Well, since this represents these are all equal increments, the number of plants. The number of, or the change in B would represent the number of bees per plant, per additional plant, or per added plant. So in this case, we would say that if you add if you go from having no plants to 1 plant, you're going to increase your bees by 3 bees per additional plant. But if you go from 3 plants to 4 plants, you are going to increase your bee population by 9 bees per additional plant. So what does the change in B tell us? Well, the change in B, this tells us the additional population. Let's put it that way. So additional population, and really that's just a simplified way of saying the bees per additional plant. Okay, well, if you look at the change in B, that is the change in the additional population. Okay, so the additional population is 3, and then 5, and then 7, and then 9, and then 11. But the amount of additional population is increasing. So it doesn't only increase by 3 bees per plant, but then it increases by 5 bees per plant, which is 2 more bees per plant. So we could say that that this represents the bees per additional plant per plant. So the number of additional bees that you get increases depending on how many plants you already have and how many plants you're going to add.